everyone. In this video we are going to talk about the gradient descent algorithm. So as you will see, it is basically an optimizing algorithm. There are two versions of this, batch and stochastic gradient descent. So we'll learn about it and what is the use of this, when do we apply this. So not only for linear regression type, we can apply it in a whole lot of new algorithms that we are going to learn. So this is our machine learning video part 22. So let us just start. By the end of this video, you will be able to get the intuition behind the gradient descent algorithm, understand the types of gradient descent, and understand the mathematics as well as the code for gradient descent. So we'll just try to write the entire code for gradient descent, and at the end we will also look at our inbuilt gradient descent regressor from the scikit-learn library. So let us just start. So what it is basically, it is an optimizing algorithm which is used to find the values of the parameters of a function that minimizes the cost functions. So the gradient descent is best used when the parameters cannot be calculated analytically, that is using linear algebra, but it must be searched for by an optimizing algorithm. The polynomial regression for just 2 degree was quite time consuming. So what we have to do basically in linear regression, we saw that by doing 2 times partial derivatives, we can find the value of m and c, we can find our optimal values. But we also saw that in case of polynomial regression, there can be like more than 2 degree. So for the 2 degree polynomial regression of our code, which we saw in the last video, so that code was itself quite time consuming and quite hectic. So what if we have a data set which is a bit more higher dimension? Can we apply those higher dimension and solve it using our normal linear algebra? No, of course not. We won't be having then a simple 2D matrix. We may be having a 3D matrix, we may be having a higher degree polynomial. So it will be quite difficult to actually calculate all the parameters values like y equals to m1 x1 plus m2 x2 all the way till mn xn. All the values of m1 m2 and mn till mn would be really difficult to calculate by just using linear algebra. So we use this gradient descent algorithm. So it is not specific to linear regression, but can be applied as a substitute for any kind of algorithm. So it is basically an optimizing algorithm. So what is this? If you can recall, this was our cost function. So what is the cost basically? Was we subtracted our real value from the expected values and we just square it, and this is basically our mean squared error, and if we sum it, it can be also called as the cost function. And when we plot this data, our curves look something like this: cost function versus m. So what we can do basically, this m is not the exact slope. So if we see where cost, m min, and the minimum values of the function. So suppose you are at this point, your dataset, the analyzing dataset is at this point. Now you want to reach this minimum value of cost, and what is the you want to find at what value of x I would get the minimum value of cost. So what you can do basically is you can draw a tangent to this. You can see the slope is positive. So if your slope is positive, you have to go backwards, and if your slope is negative, you have to go front in order to reach the minimum cost. But you also know that a negative slope when subtracted with the negative gives positive, and so you can go forward. So if we calculate the new value of m as m dash, we can write it as m minus alpha into slope of m. To just get a feeling of this formula, imagine a slope of m is positive, then m is getting reduced basically. So then m is getting reduced, so we are traversing the left. So we are reaching the bottommost point where the cost function is minimum. Now suppose our slope of m is negative, So we are traversing in the forward direction, we are basically adding to m, because negative time negative is positive, and so we basically reach our minimum cost function. So this is the basically working method to get to our minimum cost function. We can do it stepwise, we can do it batch wise, depending that we can write various kinds of code. So we will see that if our slope is positive, then the selected m is to the right of m min. I explained you this thing. So similarly you can find the intercept also, similar formula would appear, and you know that the slope of m is basically the partial derivative of the cost function, and slope of c is nothing but the partial derivative of cost function with respect to c. And I showed you what was the cost function, basically y minus m of mx1 plus c whole square. So it was whole square, so if you do the derivative using normal chain rule, you will get this, and for the cost function with respect to c you will get this. So what will be the use of this? Basically we will use it in our code to write the formulas to calculate the cost function. We can use this stuffs in our code. So let us just understand the graphical way. So that alpha what we said was our learning rate. Basically this alpha is known as the learning rate or the learning parameter. So how to adjust this alpha is the skill that will be required to actually set up this algorithm working in an efficient way. So if you see, the learning step should get reduced and should get converged at this point. But what if our step is something like too huge? Suppose we jump directly from here to here and then we jump here. So we may end up in overshooting, right? So we may end up in overshooting with a big learning rate, and also with a small learning rate we may end up in reaching our target uh, after a long time, which may be a lot of time consuming and memory intensive. So we need to adjust our learning parameters in a very clever manner. So this is known as basically overshooting. So the adaptive learning rate is something like the performance of a model on the training dataset can be monitored by the learning algorithm, and the learning rate can be adjusted in response. This is known as adaptive learning rate. So it was basically the essence of this. So let us just now start writing a code. You know this, we have to import the libraries at first, and then we just design a data frame from the panda. So pd.read underscore csv, this data set I have used in my previous videos also. It is basically the how area of a particular plot, and the price pertaining to that plot uh, is in the term of x comma y. So these are the two values of x comma y, and we just drop our extra column within place true axis 1. So you all know this basically. So let us just directly jump into writing our code. So first we define something known as step gradient. What would our step gradient take? So we understood that in each step we need to calculate our new slope and the new intercept. So depending on how many iterations you want to do, at first you must get an essence that we have to write a code, something a function something like this gradient, which would take the points, the learning rate, and the number of iterations. It would just go in the range of number of iterations and just print all the values of cost function. So this cost function will take the points m and c and just calculate on the you know what is this points? This points is basically a 2D array, 2D numpy array basically. So this 2D numpy array x comma m is basically the number of x comma y pairs. So for the number of x comma y pairs we traverse, and this x will be just like, this is the ith training data, and this is the column, 0th column, and ith row. You know this is the ith row and this is the first column. So we get the x and y points, and we also calculate the total cost, and we return the total cost here. Then we should calculate the step gradient, which would be the m, which would return the new m and c values at each step. So the step gradient will be something like, it would take the arguments as points, learning rate m and c. At first we can assign it to 0, and then we take the number of x comma y pairs. For I in range m, we basically find the x and y, and we just find the m slope. What will be our m slope on the basis of the derivative? The m slope is basically the partial derivative of the cost function with respect to m and with respect to c. And after these iterations we would just get our new m, which it will be equal to m minus alpha into n slope. You have so I by the now you should understand how we are traversing at each step to calculate the new m and new c values, and we are basically returning it. So in the gradient descent main function, we are just traversing through the number of iterations. We are just returning up the new MNC values. We are putting those MNC values into our cost to see what is our new cost. Has it reduced or not? We are just verifying it, and let us just see the output. So this is our run function, which would basically just take the learning rate, number of iterations, and just call the function. So this doesn't have much values, much relevance, but it is just essentially, you may not write a function this way, or you can just run this entire thing. You can just run this entire code also. So if you just run this run function, what would happen? So if you see, I started with the random value of learning rate and the number of iterations as 10. We can see that our value is overshooting our cost function. So I showed you an example of the overshooting. So we are taking a large steps, due to which our cost function, instead of minimizing, is increasing dramatically. It is increasing dramatically, and which is leading to an erroneous value of m and c. So what we should do, we should then reduce the learning rate to an adjustable value, and after the number of iterations we set it to 20. So we basically find our cost function reduces, and then it typically converges at this point. You can see all the values are same, so it typically converges, and in this case we find the correct value of m and c. So this would be the correct value of m and c, because it typically converges at the vertex of the parabola shape function. So we can all till the last slide, it was our physical implementation of gradient descent algorithm. We may not do it this way. We can just use the ensemble lib module from the sklearn library. We can just import gradient descent, gradient boosting regressor. We can design an object handle. We can just fit the object into the numpy array of data frame, and we can just take the, this is basically column represents all the rows, and the first column we can just reshape it to make it to a 1D array, and then we can just feed the column values. So we can just calculate after training, after fitting, basically we can just calculate on the same data set I have shown this, when our score will be 92.94%. So yeah, I think these concepts are now really clear to you. So let's meet you all in the next video. Thanks a lot.